Now that we've been able to define redox reaction in terms of electrons transfer, we should be able to show how the electron is being transferred using half equations. Remember, during the electrons transfer, an atom or an element transfer electron to another element in the reaction. So it means we can write half equation to show the electrons loss from one atom or one element, and also write another half equation to show the gain of electron by the other atom. So let's look at the reaction between magnesium and oxygen again to form magnesium oxide. So we're going to write two half equations for the two processes that we have here. Remember, the first process is loss of electron. We're going to write a half equation for this process, and the second process is the gain of electrons. So we're going to write the half equation for the gain of electron by oxygen. So it will look as if we split the whole equation into two. We split it in terms of magnesium and in terms of oxygen. So let's have a look. So this is the magnesium half of the equation. So this is the oxidation side. I call it oxidation half of the equation. And this is the reduction half of the equation. But I've not written it because remember I said that half equation shows the electrons transfer in the reaction. But here we've not seen the electron transfer. So I'm just telling you how we split the equation into two to give us two half equations. So let's look at the magnesium half of the equation. This is magnesium atom. Remember, it has two valence electrons, that is two outermost shell electrons. So I use this dot to represent them. Magnesium will have to lose these two electrons in order to undergo oxidation. So we're going to indicate that by writing minus 2 electrons. So I will just write minus 2 electrons here. Minus 2 electrons means magnesium has lost 2 electrons. So when magnesium lost 2 electrons, remember last time here we have Mg2 plus. So we're going to write Mg2 plus. 2 plus means it has 2 more protons than electrons because it has lost 2 electrons. And remember, the charge of proton is plus, so it means 2 more protons or 2 electrons less. This is the way I write the equation for loss of electrons, because we can see it easily that we can even translate this into word. We can say magnesium lost 2 electrons to become magnesium ion, and this is oxidation. But in many textbooks you will see it in this way, which is also acceptable. So you can use any of the two. This one is acceptable, the other one is also acceptable, and this is the other one. They will write Mg, so, and then they put the arrow here. So remember, in mathematics, when you move from one side of the equation to the other side of the equation, the sign will change. So this will be, instead of minus 2 electrons here, so it will be plus 2 electrons on this side. So let me just move it. To be plus 2 electrons, and it will be magnesium ion. So it means magnesium lost 2 electrons to become magnesium ion. Also, if you add 2 electrons to magnesium ion, it means it will come back to magnesium atom. So I prefer the first one because it is more explanatory. So this is the magnesium half of the equation, which indicates oxidation. So let's write for oxygen half of the equation that indicates reduction. So for oxygen, remember here we have oxygen molecule, O2. So it will be easier to use oxygen atom for the explanation. Then we now transfer it to oxygen molecule. So I will write O as oxygen atom. So remember, we said reduction is gain of electrons. So it means oxygen atom gains how many electrons? The 2 electrons lost by magnesium, oxygen atom will gain it. So it's going to be plus 2 electrons. Plus means gain of electrons. So oxygen atom gain 2 electrons from magnesium to become oxygen ion, and then that will be indicated here as it has 2 extra electrons. So negative is the charge of electrons, or minus is the charge of electrons. So this is gain of electron. You can also see it as well. Oxygen atom gains 2 electrons to become oxygen ion, and of course it is going to be the reduction half of the equation. But we are not done yet, because this is oxygen molecule, not oxygen atom. So, but it is not going to be difficult. What we are going to do is just to multiply all this, everything in this equation, except this reduction anyway, by 2. So when we do that, an oxygen atom will become oxygen molecule, O2. You don't write it here, you write it as oxygen molecule. And then if one oxygen atom gains 2 electrons, so it means 2 oxygen atoms will gain 4 electrons, which is same thing as 2 multiplied by 2 here. And then we are going to have 2 oxygen ions. So for oxygen ion, we put 2 here, and then we write O2 minus. So we have 2 oxygen ion, and then of course the process is reduction. So this is the oxygen half of the equation, and this is the reduction, magnesium half of the equation. Magnesium undergoes oxidation by losing 2 electrons, we've seen it here, and oxygen undergoes reduction by gaining electron. But there is a disparity here. How come magnesium will lose 2 electrons and oxygen will gain 4 electrons? So I will explain that quickly. So if you look at the whole equation, you will see that magnesium, the equation is balanced. We have one atom, it's not balanced actually, so I have to balance the equation. There is 2 atoms of magnesium here, and the 2 atoms of oxygen. So I have to put 2 here to balance the equation. So, but if you look at the half equation here, you will see that if you combine these 2 half equations to give us this full equation, it is not combinable now because the equation is not balanced yet. So we have to balance this half equation as well, and it is so simple. We have 2 magnesium atoms here, so it means we will multiply the entire magnesium half equation by 2, the way we did for oxygen last time. So if you multiply everything by 2, this will be 2 mg, and this will change from 2 electrons to 4 electrons. So I will change this to minus 4 electrons. That is, 1 atom of magnesium loses 2 electrons, and 2 atoms of magnesium will lose 4 electrons. So, and here, when we have 2 atoms of magnesium here, definitely we must have 2 ions of magnesium at this side as well. So you will see that everything, the equation is balanced now, because we have 4 electrons being lost by magnesium here, and 4 electrons being gained by oxygen at the other side here. So let's just combine the 2 equations together. If you combine these 2 equations together, we are going to get the whole equation back again. So we combine the 2. When we are combining the equation, we will remove the electron, we cut out the electrons. So we know that the equation is balanced actually. Minus 4 electrons plus 4 electrons equals no electron. So we write for magnesium, it will be 2 mg plus O2 to give us This is one, remember this is magnesium ion, so I just write 2 Mg. So just for the sake of explanation, 2 Mg, 2 plus, and that 2 O2 minus. Remember they are together, just like in mathematics. If you have 2x and 2y together, it is the same thing as 2xy. And that's what we want to do now. So we can just open the bracket. If you want, you can open the bracket here, and you remove the 2 here. So we're going to remove this 2 and remove everything. So we remove the 2, so we have O2 minus. And this is same thing as 2 MgO. 2 MgO. So I can rewrite it 2 Mg plus O2 give us 2 MgO. So this is the full equation from the half equation. So they can ask you to use the half equation to show electron transfer, and then we've seen it now. Minus 4 electrons means electrons is being lost by oxygen, and that is by magnesium, and that is oxidation. And plus 4 electrons mean electron has been gained by oxygen, and that is reduction. And that's it.